Hello students, in this video we will start with the chapter Refraction of Light. Now you have seen that generally light travels in a straight line, and because of this, if an opaque object lies in the path, a shadow of object is formed. We have also seen in previous classes how these shadows change due to change in relative position of the source of light and the object. But light can bend under some circumstances, as we will now study in the chapter. Now you have studied about reflection of light also. So there is a difference between reflection and refraction. Refraction is when the light changes its direction when going from one transparent medium to the other transparent medium, and that is called as the refraction of light. Let us understand refraction of light with the help of a small experiment. So we have taken a transparent glass and we have added water into it. Now we have to dip a portion of the pencil vertically in water, and you have to observe the thickness of the portion of the pencil which is there inside the water. So when you see the thickness, what do you observe is that the portion of the pencil inside the water appears to be thicker, as you can see in the picture as well. And the pencil which is just above the surface of the water, it appears to be broken near the surface of the water. So why does this happen is, this is because of refraction. Because when the light is changing its direction from one transparent medium to another transparent medium, there happens a refraction. Now another activity to understand the refraction is with the help of coin and a glass of water. So you have to keep a 5 rupees coin in a metallic vessel, and you have to slowly go away from the vessel and then stop when the coin disappears. You have to keep looking in the direction of the coin, and then you have to ask your friend slowly to fill the water in the vessel, and then again at a certain level you will be able to see the coin. Now this is again happening because of refraction, because earlier when there was no water, there was no refraction was happening. The light was, the incident and reflected rays were there. But when refraction is happening, there was a bending between the two layers, the air and the water, between the two transparent layers, between the two transparent medium, and so there was a refraction. And this is the reason when you were observing the coin from the same height, same position, earlier you were not able to see, but when you add water you were able to see. Now we have another activity to understand the refraction of light. So this activity is by using a glass slab. So we have to keep a glass slab on a blank paper, and you have to draw its outline as is shown in the figure PQRS. Then you have to draw an inclined straight line on the side of PQ, and in such a manner that PQ should intersect at N. Then you have to pierce two pins vertically at 2 points, that is A and B, along the line. Then next you have to look at the pins A and B from the opposite side of the slab, and by looking from the opposite side you have to pierce again two pins, that is C and D, so that the vertical image of A and B are in the line C and D. Okay. Now you have to remove the chip and the pins and draw a straight line going through point C and point D, so that it can intersect SR at M. Now join M and N together, and you will observe that the incident ray, which is A and N, and an emergent ray, that is M and D. So now what we had drawn from that, the first refraction that occurred when light ray enters the glass from the air at N on the side P and Q. The second refraction occurred when light ray uh, enters the air through glass at point P on the side S and R. So the first refraction, the angle of incidence, that is I, while for second it is I1, as you can see in the picture as well. The angle of refraction at N will be R. Now we all know that angle of refraction is equal to angle of incidence. Now here I1 is equal to R. In the second refraction, the angle of refraction is E, which is equal to I, that is angle of emergent. Now on both the parallel sides, that is PQ and RS of the glass slab, the change in direction of light ray is equal but are in opposite direction. And so you can say that the light ray MD emergent from the glass slab is parallel to the incident ray AN on the side of PQ. And also the emergent ray is somewhat displaced with respect to the incident ray. Now, as you have studied about the laws of reflection, there are few laws of refraction also. We have two main laws of refraction. First is that the incident ray and the refracted ray at the point of incidence in the figure, which is N, are on the opposite sides of the normal to the surface of the glass slab, that is on the point CD. And three, that is all the three, incident ray, the refracted ray and the normal, they are all in the same plane. And the second law is that for a given pair of media, it can be air or glass, the ratio of sine I to sine R is a constant. Now, if you're wondering what is I and R, we all know I is the angle of incidence and R is the angle of refraction. Let us now understand about the refractive index. So what is refractive index? The value of refractive index is different for different media. The change in direction of light ray entering different media is different and it is related to the refractive index of the medium. And that is the reason it is different for different media. Now the refractive index depends on the velocity of light in that particular medium. You can also calculate the refractive index of some substances with respect to the vacuum, and the refractive index of a medium with respect to the vacuum, we call it as the absolute refractive index. Now in this table, there are few refractive index which are given for few substances like for air, for ice, water, alcohol, kerosene. All these refractive index are fixed and you just have to use the quantity which is given here and then calculate in the given formula. So to calculate, there is a formula for refractive index. For refractive index, velocity of light in the medium 1, always we use two mediums for refractive index. The velocity of light in medium 1, we consider it as V1, and for medium 2, we consider it as V2. So the refractive index of second medium to the first medium will be 2n1, and which will be equal to velocity of medium 1 upon velocity of light in medium 2. So which are the values? You have to put in the values and you have to get the answer.